The idea that everyone should follow the same diet, whether it's low-carb, plant-based, or Mediterranean, has shaped decades of public health advice. But science is moving beyond this one-size-fits-all approach. Thanks to advances in nutrigenomics, the study of how genes interact with nutrients, we're beginning to understand that the best diet for you may be different from the best diet for someone else. And in many cases, your DNA holds the clues. Nutrigenomics explores how your genetic makeup influences how your body responds to specific foods, nutrients, and eating patterns. It explains why some people thrive on a high-protein diet while others see better results with complex carbs, why some individuals metabolize caffeine quickly while others experience anxiety or insomnia from a single cup of coffee. It's not just about preferences, it's about how your cells are wired to handle nutrients, how your enzymes function, and how your metabolism operates at the molecular level. For example, variants in the FTO gene are linked to greater hunger cues and a tendency to store more fat. Certain APOA2 gene variants may affect how saturated fats influence cholesterol. People with variations in the TCF7L2 gene may respond poorly to high-carb diets, raising their risk for type 2 diabetes. These genetic quirks help explain why two people can follow the exact same diet and exercise regimen, yet see very different outcomes in weight, blood sugar, or cholesterol. But here's the deeper insight. Personalized nutrition doesn't just promise more effective weight loss, it may also help prevent disease. By tailoring diet to genetic risk, it becomes possible to target early warning signs of metabolic dysfunction and take action before symptoms ever appear. For someone with a genetic predisposition to insulin resistance, reducing refined carbohydrates and boosting omega-3 intake may keep glucose levels stable for years. For another person with inflammatory gene variants, a polyphenol-rich anti-inflammatory diet might lower long-term cardiovascular risk. This kind of customization could revolutionize public health, moving from reactive treatment to proactive prevention. And yet, here's the caution. Genetic information alone doesn't dictate destiny. DNA provides a blueprint, not a fixed outcome. Lifestyle, environment, microbiome composition, stress, sleep, and epigenetic factors all shape how your genes are expressed. So, while genetic testing can offer valuable guidance, it's not a magic ticket to perfect health. There's also a risk in misinterpreting or overvaluing these tests. Many direct-to-consumer nutrigenomics kits offer vague or generalized advice, and not all are backed by strong science. True personalized nutrition requires a thoughtful integration of genetic data with clinical markers, dietary history, and lifestyle context, ideally under the guidance of a trained professional. Still, the potential is enormous. Moving beyond blanket dietary rules to plans based on genetic individuality represents a major leap in how we understand nutrition. It shifts the conversation away from rigid categories and toward a more compassionate, precise model of care. For people who've struggled with diets that didn't work or who've been unfairly judged for not seeing normal results, this approach offers validation and hope. So while your genes may not determine your fate, they can help light the path. Personalized nutrition, when done right, doesn't just change what's on your plate. It changes how you understand your body, your health, and what's possible in your pursuit of long-term well-being.